Okay, I will get us started. You ready, Carmen and Bryce? Hello, I'm Rob Eddy. I'm the Technical Director for Resource Innovation Institute. Welcome to this workshop on aligning your SOPs with HVAC for your controlled environment agriculture facility. Our agenda today, as you see before you, we've got 90 minutes for this. It's going to be a fantastic talk. We've worked very hard on this one with our panel. Our panelists have spent more time on this than anyone we've done so far. So I think you're going to really enjoy this one and get a lot out of it. This is the third in the series of 4 that workshops that we're doing, sponsored by, thank you very much, Southern California Edison, for being our sponsor on this. You've been a great group to work with, and we can't wait to do this one and the next one. Here's our agenda today. I'm going to give you a little bit of introduction to who RII is and what this webinar series is about. We'll talk about these topics: how CEA crops use air and moisture, HVAC best practices, benefits of high performance HVAC, CEA HVAC systems, more detailed, optimizing those, controlling and automating those, commissioning those, benchmarking HVAC system KPIs. And then towards the end, we're going to have a real good 10 or 15 minutes with Thomas Lord from SCE, and we'll be talking about some of the incentive programs that you can join. So we really hope that you stick around, because that's where you can really get a financial benefit from being here and learning so much about HVAC today. So a little bit about RII, that we are a non-profit data-driven organization. A little bit of our history is that we've been around since 2016, serving the cannabis industry up until late 2019, 2020, when we received a USDA grant to use this expertise and the network that we created and the systems that we've created to serve the CEA community. We have a broad network of people we've brought together over the years: producers, regulators, governments, state, local governments, and we bring all those folks to the table. And that allows us to do things and collaborate on projects and trainings that other entities couldn't do alone. So we measure, verify, and celebrate the world's most efficient agricultural ideas. We measure by using our Power Score database, where you can, as a producer, you can log in and enter your energy and water usage, and also your facts about, statistics about your facility, and then we can generate KPIs for you, and then you can watch those year over year. And as they improve, as you implement best practices. Okay, those best practices are what we also are known for. We get working groups together of industry experts, and we generate these kind of distill their expertise into best practices guides, and we use those as a curriculum, let's call it, for the kind of webinars that you're seeing today. And then we do case studies that shows how people have used these best practices to improve their KPIs. So we celebrate those and celebrate the leaders in the industry who have implemented those best practices. Next slide. So like I said, we bring everyone to the table, and baked into everything that RII does is resource efficiency. So when we're talking about HVAC or we're talking about irrigation, we're always bringing in the conservation of natural resources to those activities within CEA. So that's something that not every group will be doing. And this kind of training that we provide is unique because it's always based on resource efficiency. Next slide. So the Technical Advisory Committee is the sum of all of our working groups. And like I said, we get them together. They're from industry, including growers, including the supply chain, the vendors from the supply chain, sometimes regulators, sometimes utilities, and they are made up of RIA members, and they help us distill that expertise, as I said. And then they help us when we are done with a best practice guide and begin to promote it and begin to make curriculum out of it and do training. We ask the Technical Advisory Committee, those who want to come and join us and help us with the rolling out of that information, with the education. So it's a great relationship. If this feels like something you'd be interested in as a producer, you can contact REI and become a member and join us in this activity. Carmen, next slide. So here's some of the guides we've done already for the cannabis industry. We've done lighting and energy efficiency and automation controls and HVAC. For the CEA industry, we've already done facility design and construction, lighting and HVAC. Right now, we are working on water circularity, again, to ways to design the waste out of the water waste out of CEA production. And next year, we'll take on a new group of controls and automation for CEA, which will also be exciting because there's been a lot of, even since we've done the controls and automation for cannabis, there's been a lot of technical advancement and a lot of new automation and sensor technology. And back to the water circularity one, we believe that this will be the first such document that really in one place shows you how you can both conserve water and also remediate it and reuse it. Next slide. You can download these best practices guides. They're absolutely free and they're on our website. And Carmen can put that link up on our chat. And again, so there's a lot of information from this presentation you're getting today is from our best practices guide on HVAC. Today's speakers are myself. Again, I'm from RII, been with RII for 5 months now. And I'd like to introduce Adrian and Brian and have them tell a little bit about themselves, the company they work for, and some of the expertise they like to share today. Adrian, why don't you start?
That sounds great. Very nice to meet everybody, see everybody today. My name is Adrian Giovenco, and my company is called Inspire Advanced Transpiration Solutions. We focus on providing integrated HVAC and dehumidification systems and control, purpose-built, plant-centric sequence of operations to control these indoor spaces, both for cultivation spaces and curing spaces. We serve all of North America. Based in San Francisco Bay Area. And we have extensive experience, particularly in the cannabis industry, and particularly within indoor cultivation spaces and large-scale curing spaces. And I look forward to meeting everybody today. I would love, with a small group here today, I would love to hear maybe a little bit about the composition of the group that we have, so that we can target specifically the conversation as we go through to exactly what you be looking for. Great to meet everybody.
That's a great idea. In the chat, if you care to, if you're listening to this, you could type in the chat whether or not you're a grower or a designer or a tradesperson in the industry, however you want to describe your role. Brian, why don't you go ahead and introduce yourself to everyone?
Thanks, Rob. Brian Kammers. I'm a PE in Wisconsin, professional engineer in Wisconsin. I work for Desert Air. Desert Air has a long history in dehumidification, starting in 1978 with pool dehumidification. We got into this market 6-7 years ago and have continually improved our products to provide that perfect day, if you will, for indoor agriculture, typically, as Adrian was saying, for the cannabis space. But we have forays into other areas as well.
That's fascinating. Are pools about as close as you can come to a plant growth facility? Do they give off a lot of water vapor and become a challenge for HVAC, Brian?
Yes, they are. And you need to size the equipment based on the moisture removal capacity. Moisture removal efficiency also affects the operation of it. And the same things go for indoor agriculture. You have to be able to remove so much evapotranspiration that's happening. So there is a pounds per hour capacity requirement in indoor agriculture as well.
Fascinating. It makes a lot of sense to me too, because I think I told you the story before that where I worked before at Purdue University, taking care of their greenhouses. Once they put a meter on our facility, they came running over a couple months later, not having realized that I was the fourth largest draw on a campus, public university of 150 buildings. And like number 5 was the aquatics building. And I was kind of surprised by that I didn't realize how much energy. And now it's beginning to make sense that it's not necessarily pumps filling up a pool. It's the HVAC it takes to remove all that vapor, water vapor from the air. Next slide. A little bit about the industry before we get into our technical talk. Nothing to say other than California is big and is leading in most sectors of the agricultural, or I should say the horticulture productivity. With cannabis, over 6,000 licenses. And you can see the different types of licenses in the state of California, from specialty cottage to large, to nurseries, to processors, both outdoor, indoor, and mixed light facilities. A $4 billion legal market in cannabis just in California, and with an estimated illegal sales of about twice that, about 8 billion. 4 billion legal, 8 billion illegal. Next slide. And California, like I said, is leading in most other horticulture production under CEA conditions and under protected conditions. You can see this is a great graph that Carmen has made for us, a chart for us that she's put up here. The bright red is tomatoes, easy to remember that. You can see just how far California leads the other states in tomatoes. And then the green is other vegetables, okay, and huge production of those. The pink is fruits and berries, again, leader in that, and not the leader in mushrooms, that's the brown, but only because Pennsylvania has a massive mushroom market, but second only behind Pennsylvania. And of course, our floriculture industry is very large as well, and historically been large, not only cut flowers, but things like poinsettias and bedding plant. A lot of the research goes on in California, so that the floriculture industry does. Next slide. Purpose of today's workshop, to encourage cultivators to participate in the SCE, the California efficiency programs. Of course, to convey scientific insights and industry expertise today directly to you all, and find the best ways to translate them. And also, lastly, to help energy efficiency programs achieve their savings goals through education and knowledge sharing. And again, big thanks to SCE for sponsoring this. Next slide. The learning doesn't stop today. We have a virtual classroom that you can access, which has that not only recording, it'll have recording today's webinar, but it has the other 2 SCE sponsored ones we've done already. And again, there's going to be 4 total. You can see those, you can access those recordings, tip clips, which are short little videos that give advice that in very digestible chunks, downloadable resources like from our catalog, these HVAC best practices guides and other best practices guides, and also the SCE and PG&E state program tools, which we'll talk about a little bit later. Lots of great free information and tools that you can use from these utility companies. I'm just going to look over here and see. I know that Adrian had asked what kind of folks we had out there. We've got a few people have responded, Adrian. We have controls engineers, HVAC engineers, energy services company, another engineer for MEPs. And so far we got 4 or 5 respondents, and they've all been on that side, not on the grower side. We've got the next number 4 in our series will be the controls and automation best practices for efficient greenhouses and indoor ag. That'll be on December 13th. And then the fun isn't over then. It just keeps rolling on, because PG&E has also funded workshops for us. And you can see those 5 titles here in the black and the dates that we'll be presenting those. And some of those are really unique, and I don't think have been done anywhere else. The craft cannabis, the retrofits, you just don't typically get those kind of webinars for the CEA industry. Okay, we're going to jump into our technical talk. I'm going to kick us off today with kind of a plant science minute. I won't take up too much of your time, but I think it's important if you weren't trained as a horticulturalist to get refreshed on this every once in a while. So how do plants use water and air? Well, simple one, I think we all think of, or maybe we don't, maybe we forget that the photosynthesis equation, as you see before you, includes water in it. Plants split that water molecule. They get carbon dioxide from the atmosphere, obviously, they get water from the roots, and they split those molecules and make glucose. It's all about making sugar. From sugar, plants can make everything else that they need. And of course, while they're making sugar, they're also making energy. So of course, that's one way that plants are using water, but you would think that would be the majority of the water use. There's, seems so important, but actually only about like 1% of the water plants take up is required to create all the photosynthesis that the plants need to create all that sugar. What they're really using water for is for cooling themselves, for thermoregulation. I just put this picture up just to remind us of that. It's a heat map or infrared photography of some cannabis plants under different lighting conditions. But the plants are taking up water to cool themselves. That's why so much of the water ends up in the air, as vapor, is that plants have to do this. I should also say that water also provides a buffer so that they don't get too cold as well. So they're mostly water, and that does help buffer the temperature when they're exposed to different temperatures in the atmosphere. Next slide. And of course, water is needed for a few other things. It's how nutrients are taken up through the roots, is being dissolved in water. Okay, and there's two other. Water is the universal solvent for all chemical reactions inside a plant. So that's another reason. And water is what keeps a plant upright. That turgor pressure in the cells is what keeps a plant upright. And as we all know from what happens when you take away water. So let's jump to air next. Go ahead. I put this slide up because I thought a lot of you would enjoy this. This is computational fluid dynamics diagrams of airflow in a vertical farm, and I'm not going to talk about this. It's not my area of expertise, but it does indicate why we're so obsessed with air in CEA. It's because air, we need to have it uniformly moving and distributed because it's doing so many things for these plants, and you want uniform growth. So the air is made up of gases, and of course CO2 is what they need for that photosynthesis formula we showed you before. Air transfers heat into and out of the growth room. It transfers water vapor into and out of the growth room. It's like this bountiful river of goodness for plants. It does all these great things for it, and it also draws the water from the plant, which is how plants evolved and is absolutely necessary. Let's look at the next slide, and I'll explain this a little bit. So it took plant experts a couple centuries to figure out how in the world plants got water all the way to the top of their leaves, like a tree. They try to figure out, well, is it just absorbing water like a sponge? Are the roots pumping water with pressure? Though there's a little bit of both of those going on, but what they eventually discovered was no, what is driving that flow of water through the plant is transpiration, where it's being sucked out. It's like a straw. The plants are like a straw, and moisture is being sucked out of the ground into the atmosphere due to a difference in vapor pressure. Now, here we go. So up on the upper right are these black and white micrographs of stomata, which are little pores on the bottom sides of the leaves. And when those open up, they can absorb CO2 from the atmosphere, but they also allow water vapor to leave the plant, because that inside that pore, it's a water saturated vapor, and out in the outside the environment, it's almost always a little bit drier. So less pressure, and so that the water vapor is driven out of the plant. And because the cohesion of water, once you start pulling water out of the top of the plant, All that water is just connected through cohesion, so that it makes water, pulls it right out of the roots. And that is what's bringing up the nutrients. That's what's cooling the plant. And it's an active process. It's not passive like a sponge. It is active. The plant is opening and closing those stomata according to their needs. Next slide. And that's important when it comes to vapor pressure deficit, that what you want is to keep that plant stomata open. Because when that stomata is open, it's taking in CO2, and so that means it could photosynthesize and grow. So you don't want to have the vapor pressure too low, or the stomata will close, because there's just no transfer of water vapor from the leaf pore to the atmosphere. And you don't want that vapor pressure deficit to be too high. The plant's going to kind of freak out, and it's going to realize it's beginning to lose water at the root system. It better shut down that pore, or else it's going to go into water stress. So this is a nice chart you see here, where the yellow is indicating the VPD level that is perfect for, in this case, this is a cannabis chart. And as you increase the temperature, you have to increase the humidity to maintain a similar optimum VPD. And the optimum is about 0.8 to 1.0. And this is, again, the reason we are so obsessed with this is having the right VPD means the plant is transpiring, which means it's cool, and it's also drawing in CO2 for photosynthesis and drawing up water for photosynthesis. So I apologize for I just get too excited when I talk about plant science. I'm going to turn it over to Brian now to talk about HVAC best practices for greenhouses. Take it away, Brian.
Well, thank you, Rob. And I appreciate that picture of a glass of absinthe with a straw in it. So I thought that was pretty clever. When we're talking about these different growing techniques, we're really kind of tied to those systems of growth where the utility companies get involved. So we're not talking about outdoor grow here. We're talking about ventilated greenhouses, which historically just use outdoor air to control the temperature in the space. And then at nighttime, when the humidity would build up in the rooms, they would use a dehumidifier, typically a portable dehumidifier. And they rate these dehumidifiers using the Association of Household Appliance Manufacturers rating, which is 80-degree temperature and 60% relative humidity. The reason I bring that up is because as temperature and humidity go down, these refrigeration or dehumidification systems have less and less capacity for removing moisture. And we have a slide coming up later that Adrian will show. Sealed greenhouse is kind of the next level. So if you grow outdoors, the plant's spending all its time adjusting to the changing conditions outside. With a ventilated greenhouse, you have more limited changes. Sealed greenhouse, you're even tighter control. But when you go to that level, you have to have some sort of environmental conditioning. And we call it heating, ventilation, air conditioning, and dehumidification, HVAC-D. And what you're trying to do is offset the solar gains and a lot of times take care of the increases in humidity as it gets too high and gets out of the range that Rob talked about for your VPD. And then indoor grow, that's where you control everything. You need that HVAC-D. You're providing the lights, you're providing the conditioning, and you're trying to provide that perfect day. So instead of a plant having to adjust by changing conditions, it doesn't have to adjust. It can focus on just growing. And that's why you go from ventilated to seals to indoor, because you're trying to get a better product, whatever that might be. Now, econometers are typically not used like they might be in comfort cooling, because it's rare that the outdoor temperature is at the right, outdoor air is at the right temperature and humidity. And in a lot of cases, particularly cannabis, you're pumping CO2 in the room to help the plant grow. And if you're bringing in outdoor air, you're just going to dilute the money you spent for CO2. And there's also issues about introducing pests from the outside, wild hemp spores and things of that nature. So when we look at the greenhouse, you have certain things that are options that you can do to help with your control of the space and your energy use. Some people use curtains that can provide shade or insulate. Some just do one or the other. If you have kind of an open weave shade, you're probably keeping out some of the solar gains, but you're not doing much to insulate the building. And if you have a clear thermal blanket or curtain, you're probably still letting in the solar loads, but you're probably providing insulation for outdoor temperature, whether that be hot or cold. Now, there's climate screens that help control the amount of solar radiations that's getting into your grow room, into your greenhouse. And that can help from a couple of ways. You can protect the plants if it's really bright out and too hot, or maybe reduce the amount of air conditioning you have to put in there. And these screens can also help at night to reduce the heat loss from the space, which means you don't have to heat or provide as much heat to keep the plants comfortable, which saves energy and reduces your utility bills. And depending on what your capital budget is, these might be automated controls or manually operated. When it comes to these closed and semi-closed greenhouses, the equipment, the HVAC, tries to provide the exact perfect conditions. Now, the issue is you have to get those conditions to the plants. And the key is making sure you break up any type of microclimates. And some plants are more susceptible to initiation of mold and mildew than others. But the idea is to really break up those microclimates. And you can do that through different methods. Here you see a tube underneath the plants that are blowing up into the canopy. You can blow down into the canopy. These can be fabric duct or poly tubes. But the idea is to get the air into the canopy. Now, the air that's going through there could be conditioned, dehumidified, or cooled, either through direct expansion, and you'll see DX used a lot through this presentation. That's basically your air conditioner at your house, or chilled water. Or you want to put heat in there, particularly at night for a greenhouse. You're using either heat from a boiler or waste heat from some other operation to condition that space.
Brian, is the chilled water, I understand that's something that you would use for large facilities, or any rule of thumb that any particular, like 1 acre or 2 acres, that you say, well, now we need to start thinking about chilled water?
Well, as an HVAC nerd, I usually think in terms of refrigerant capacity. So my rule of thumb is if you get up to about 400 tons of cooling that you need for your facility, now you're starting to look at chilled water.
Excellent, thank you.
We also have a question in the chat.
Yep.
For greenhouse heating, do you ever use radiant heating of the canopy or direct heating of the root/soil to reduce space heating requirements?
I think those are both valid options to use. It does kind of depend on the age of your greenhouse and what you have available to invest. Some of these are more expensive than the other, but the soil heating, there's a lot of literature out there right now on that, about how effective that is. Rob, do you have anything to add to that, being the greenhouse guy?
Yeah, there's particularly with propagation, you will see if it's the table itself, the rooted cuttings or seedlings are sitting on is maybe a mesh top, and they'll have radiant pipes underneath it. I've not seen a greenhouse that has radiant pipes above. That's what I think of when I think of radiant heat. But and often greenhouses will have perimeter heat with hot water or steam going through the pipes. And again, that's radiant, but maybe not what our participant in the audience is thinking of. But I would point out the new research in this that's fascinating, coming out of Michigan State. Roberto Lopez has been showing that he was able to come up with these techniques where if you can put bottom heat under certain crops, I think he particularly focuses on poinsettias and other flowering crops, you can reduce the air temperature and get the same quality growth, but at a greatly reduced energy cost, because it doesn't cost as much to apply that bottom heat. That's all I got.
Okay, let's move on to the benefits of high performance HVAC. When you have a sealed building, a closed environment, like I mentioned before, you're trying to provide that perfect day, which means controlling the vapor pressure differential. And if that term is new to you, you're trying to control the temperature and the relative humidity. And the real target is keeping that leaf temperature where you want it. Again, equipment can provide the proper temperature and humidity, but you have to get the air into those spaces. And that equipment that's providing the airflow can also be used to inject CO2 and distribute it evenly through the entire grow room so that all the plants can benefit from it. The other point about keeping the control very tight is you're trying to have the plant focus on just getting bigger and healthier, try to reduce the initiation sites for things like mold or mildew, and control other pests, hopefully not introduced from the outside. Now, with all this being controlled, you can meter all the different parts and pieces, the equipment, the lights, measure the water flow. And with that, you have the data to see what your return on investment happens to be. That data is also critical so you can compare rooms to rooms, some being better than others, or a room between different growth cycles to make sure nothing's changed, because you're trying to repeat the same quality of product and make sure that quality or the product quality is very high. Now, light has a big impact on the HVAC. HID lights use more energy, and they have a lot of infrared heat that warms up the leaf temperature. And it's really the VPD at the leaf temperature that you're trying to control. So lights that use more energy tend to need more equipment. And because you're trying to offset that infrared heat being absorbed by the leaves, you tend to run the rooms cooler. And I think we mentioned before, the cooler and drier you go with equipment, the less ability it has to remove moisture. It's less efficient at controlling the humidity. On the other side, LEDs, because they don't have as much infrared heat, the leaves don't warm up as much, you're able to run a warmer room, which is good because, first of all, LED lights use 60% of the HID power, and you're running at a temperature and humidity that the equipment is more effective. And you see here, same 60-ton piece of equipment operating at 7550, 176 pounds per hour, but at 8050, 213. It's just more effective at that warmer temperature. And in terms of energy consumption, certainly the lights and HVAC really take the lion's share of it. So if you can have systems that are efficient, lights that are efficient, you can be a more cost-effective grower. And it's all about economics. You need to compete in the marketplace. And it really, this picture promotes the idea of sub-metering as much things as is important to you, so you can see where that energy is going. So you can see when things are getting out of their operational range and react to it. So you need to figure out what equipment you need and the purpose it's going to serve, whether that's just sensible cooling, dehumidification, or integrated. And you have to make sure that you design a system that gets that airflow into the plants. So HVAC equipment provides both temperature and humidity control. Now, a lot of growers will have different set points depending upon the maturity of the plant. This is particularly true in cannabis, where they might have a certain VPD when the plants are little babies. And when they get bigger, you might have a higher VPD. And right before pre-harvest, you might drop the temperature to freak the plant out, think winter is coming. And you need to look at all those conditions to make sure your equipment can handle it. And if not, come up with either different targets or different equipment selection. That equipment has to modulate through that whole range of plant maturity, the whole range of different amounts of evapotranspiration. So when the leaves are small, you're not having too much humidity. When leaves are numerous and big, there's a lot more moisture, and that equipment has to react to it. So you want to monitor the VPD, and if that's a term you don't like, the temperature and humidity, the system operation, and with submarine, you can see where the energy flows. And you can look at the impact of irrigation on energy or plant take-up and the temperature and humidity conditions, and monitor that. Going on to different HVAC system types. Oop, there we go. Thank you. In greenhouse, I mentioned before, there's just usually ventilation with air blowing through it. And if you get more sophisticated, you have some type of heat exchanger. This could be what we typically refer to as a swamp cooler. You could have a energy exchange wheel, a total energy exchange wheel to help control the climate in there. The greenhouse, as opposed to outside, is going to have tighter set point range, but not as tight as a totally closed system. One of the things that I mentioned, swamp cooler, that's also known as evaporative cooling or direct evaporative cooling. And we're going to talk about that a little more in the next slide. That's basically to cool the outdoor air coming into your green space while adding moisture to it. Stepping up from there, you have air conditioners. Typically, these are comfort cooling air conditioners, so they don't have a lot of ability to remove moisture. And they're partnered with standalone dehumidifiers. Again, we have the same rating there, so people do get tripped up by taking that rating and then putting it into a room that isn't operated at that condition and being surprised that the performance is not the same. But the standalone dehumidifiers also put heat back into the room as part of the refrigeration process, which that comfort cooling air conditioner has to take care of. And then there's 2-pipe chilled water systems to cool these rooms down. And at the top end, the one where you're controlling everything, the integrated HVAC D, it has cooling and dehumidification. Here you see that nomenclature DX standing for direct expansion, just like at your house. Your house has an air-cooled condenser on it, but they can also be water-cooled. And then Rob asked me the question about what size do you go to chilled water. When you get to, say, 400 tons, you start looking at chilled water systems that are 4-pipe. 2 pipes are chilled water, 2 pipes are hot water. And these chillers can be driven by a gas motor, if you like. We call them combined heat and power type systems. Certainly, you want to have some heat recovery situation. If you have a bank of modular chillers, some of those might be heat recovery, so you don't have to use new energy to reheat the air or keep the room warm enough for the plants. So evaporative cooling works best when the outdoor air is dry. The bigger the delta between the indoor and outdoor, the more effective these coolers are. The water just drips across the media. Air comes through it, typically pulled by a fan, and that evaporation effect cools the outdoor air and puts moisture into the air. And the slide here says recommended annual cleaning. I might take a little exception to that, particularly in areas where you have very hard water. There is a mineral buildup on this media, particularly calcium carbonate, and that needs to be removed, or you start losing the effectiveness of that evaporation. And these again can be manually operated or automated to turn on when you need that evaporative cooling effect.
I can jump in with some experience with managing these and using these. I managed a greenhouse at Purdue in Indiana, and in the heat of the summer, under the most humid conditions, we could bring the temperature down about 8 degrees Fahrenheit, cooler than outdoors, but that's all. I mean, 8 degrees, maybe in the spring or the fall, where, like Brian was just describing, we could maybe get 20 degrees because the air was drier. But that's about all we could do. Now, my lucky friends who lived in drier climates could get what, 20, Brian helped me at 25, 30 degree Fahrenheit drop in temperature if you have a very dry climate. So it's very, very effective. But the fact is, we still use it in places like Indiana because it's just, we can't afford anything else. It's only recently that greenhouses started having air conditioning, as I'm going to call it for a simple term. That just wasn't around. The only people who had air conditioned greenhouses 10 or 15 years ago was Monsanto, Bayer, and Dow AgroSciences and their R&D facilities, and a handful of small ones at universities. But now, particularly thanks to cannabis, a whole new market has opened up to find better ways to cool greenhouses. I'll leave it at that, but just want to give that insight.
Another reason to be thankful for cannabis, Rob?
Yes, exactly. Cannabis has brought a lot of benefits for the entire CEA community, for the research community, because the great minds that have gone into inventing new technology and then the entrepreneurs who have developed it need to be credited for that.
Oh, my mind went somewhere else. Next slide, please. When you look at just comfort cooling type air conditioners, all going to be rated by AHRI. That's a energy efficiency rating, EER. And these could be just like standard rooftop pieces of equipment. They could be variable refrigerant flow, VRF type systems, mini splits that might have the condensing units outside and just the fan and evaporator indoors, and then chill water systems. And for the most part, these are limited in their capacity, severely limited in their capacity to do any dehumidification. So the need is there for other dehumidifiers in the room. They could be portables, and typically they are, or you could have some dehumidifiers that can reject the heat outdoors and really don't affect the cooling load of your regular comfort cooling air conditioner. So also remember, not all dehumidifiers are the same. There are some built for this application. I wouldn't be putting my basement dehumidifier in here. You need to get something that's specific for that environment. But also remember, the heat that's generated by those dehumidifiers goes into the room, and that creates a load for that comfort cooling air conditioner. Here's another product, and I mentioned this earlier about having an enthalpy wheel. There isn't really any certification for this type of device. The idea is that you're exchanging outdoor air energy with indoor air energy, and you're keeping the airflow separated so you're not introducing any pests, assuming that nothing gets through that heat wheel. So it can provide cooling and dehumidification for all climate zones. Again, probably more effective in dry climates to add moisture to the air. The heat exchanger provides a efficiency baseline. It provides, I hate to say it like this, but free cooling, if you will, free energy from that exchange. And because these are enthalpy wheels, typically they're going to have an efficiency over 50%. If it's just a sensible wheel, not doing any moisture exchange, that's when you get into the lower efficiencies. Now, you see in that picture here, it's going through the wheel, and you see some compressors. When it's going back into the space, that air going through the evaporator is cooler and drier. So the compressors are not quite as effective. As I said before, as the temperature and humidity go down, the capacity of refrigeration systems are not as good. They decline. And then we have integrated HVAC-D. Again, no certification program exists for this. Provide cooling and dehumidification, all climate zones. Some of these pieces of equipment actually operate up in Canada where it's minus 40 degrees. They use the heat or rejection from the compressors for the free energy to reheat air once it's dehumidified. And they provide really tight temperature and humidity control. So really tight control of that VPD if you have the control system worked out. Now, typically these are DX, direct expansion designs. There's package units that can go on the roof, or split systems where a condenser is outside. The larger systems are going to be 4-pipe chilled water systems with water probably around the temperature between 30 and 38 degrees because you have to get it cold enough to do dehumidification. These can be air cooled, water cooled, so really a vast array of options to meet whatever your needs are in the type of building you're operating in. And then this is a picture of the 4-pipe air handlers. You see a couple of the big ones there, air cooled. You see a Tecogen unit, the blue one, where that's for combined heat and power. They do have efficiency ratings, AHRI efficiency ratings, but typically you're going to operate these units at much colder temperatures than they're rated for. There is the option to have a water side economizer for energy efficiency. Basically, the water goes outside where it's cold in winter, the water gets cooled. Now you don't have to run your compressor and you bring it back into the building. Doesn't work for Dallas, but here in Milwaukee, it probably works fine. I would probably recommend in this kind of application, not these large chillers because they don't provide much redundancy. If you have just one large chiller and it croaks, your entire facility is dead. I would go with maybe a modular arrangement, number of chillers of a certain size, then you can have an extra 1 or 2 chillers just in case one of the modular units go down, and make 1 or 2 of them energy recovery to provide that free energy for the reheat. These units can be water or air cooled, and you see 2 air cooled options there.
That's a great point about redundancy of units, because I've heard horror stories about places just having a single unit and losing it, and quite a loss of investment.
Well, there's a lot goes on with these. I ran into a situation where, because they were trying to avoid peak energy costs, you know, the 15-minute demand charge, they set it up so that the rooms were staggered coming on, and so they ran all night long as well. So it was a 24-hour operation.
Mm-hmm.
What happened is they sized it for that, but then they found they couldn't find any employees that wanted to work at night.
Oh.
So they had to put all the units on during the day, and then they found out they didn't have enough capacity in their system.
Wow, fascinating. Great lesson learned. Thank you.
So, you know, a lot of this energy savings we're talking about with the utility companies, you have to model your situations there and show, you know, what you could have done and what you did do to try to get your rebates, if you will. One of the things we always run into is growers always report higher watering rates than actual dehumidification loads. And that's a problem from a couple standpoints. One, if you're going to size the equipment on an incorrect or too high watering rate, you've got too much equipment. And it's a waste of money in a lot of ways, because that water with the fertilizer just kind of goes down the drain. Few people are measuring their water runoff, which I think is a mistake. And even fewer people are measuring the water that's coming off your HVAC equipment, the condensate. And that gives you some idea about how much your plants are transpiring. In other words, how much watering they need. So it isn't really an energy issue there, but I think for management purposes, it's great to measure the water. And then a lot of times growers will want to give you extreme cool or dry environments as set points, and with a thought that, well, if we can do that, we can do anything. And that's really not how refrigeration equipment works. First of all, you spend a lot more money going colder and drier. You drop 10% on your relative humidity, you could have 40% more capacity required. So it has an extremely large impact. So it's really good to nail down what you really need at each maturity level of the plants you're growing.
Great. Brian, thank you so much for covering those 3 topics in such depth. Adrian Giovenco, can you take over on the optimizing HVAC system and then the controls and automation? We're doing pretty well on time as well. So thank you.
Yeah, absolutely. I'd be happy to. Thank you, Brian. That was great. We'll go to the next slide. I'm really glad that you brought up some of these anecdotes and lessons learned. This it's such a different dynamic space and with so many different needs, competing needs, that there's so many lessons learned in this industry, really, as you specifically apply a lot of the knowledge that many of us have from the built environment and other types of applications, you know, and are applying it into this particular industry and the specific need here. And all I would say really is, you know, those are probably endless, and we've all made a ton of mistakes in order to get here, of serving this space, you know, in the last 5 to 10 years, as it's really starting to come into its own. And high level, you don't have to go make those mistakes again. That's what these types of events are really for, to help share the knowledge and work with the expertise of the folks that have been serving these spaces. I think about this a lot in somewhat in paying homage to a book that we draw a lot of inspiration from, called Plant Empowerment, and where our role is really supporting plant balances and not trying to control air conditions, which is it's different, and sort of kind of a way to flip the way you think about it, different than many other built environments that HVAC systems are serving. You know, we're really trying to help support the plant in maintaining its balances in such a way that all the factors for growth are optimal at the same time. And that's why I threw up this bucket down here. It's analogous to the law of the minimum, which is more that you can dig into and learn about plant growth and balancing. But it's sort of this concept that you're only as strong as your weakest link, in the way that this is all connected and balanced together. And from our experience, and it's not just because this is what we do, it's because of the time we've spent in this industry and focused on it over the past 5-6 years. We see that the environmental control and the HVAC systems and controls of those systems really end up being the weakest link in the vast majority of the facilities that we both get involved with on, you know, serving and working together with our clients to support, but also anecdotally of almost any facility that we've ever toured and check out. And there's also a really wide disparity between different types of facilities, right? We talked, you know, a good amount about like larger scale greenhouse facilities that you may have a much different, you're trying to focus on hitting a different part of the market, and with your production, and you'll have different financial, opportunity to be able to invest in the systems in different ways. And that large scale, all the way down to very small, individualized, controlled rooms, like in a cannabis cultivation facility, you may not have the budget to be able to put it together, or 5 years ago you didn't have the budget to do it, but maybe you do now. So there's a lot that we sort of move through in this that I'm going to go over and talk about over the next few slides, and how we approach it. The graphic there on the top highlights some of the moisture dynamics that we have to be really aware of when we're designing and sizing systems. There's a lot going on in these spaces, and like Brian just talked through, you need to make sure that we're focused on really the deep, from our experience, everybody's experience in the space, the dehumidification systems and the moisture removal really needs to be focused on first and understood, really, so that we make sure that we remove the moisture in the appropriate ways at the appropriate times. It's a very dynamic load that completely flips. And yes, there are analogies to an indoor pool facility and in natatorium types, but you don't, like, I don't know what the metaphor would be, but that pool doesn't stop emitting moisture half of the day, or reduce it down by 50 to 75%, for half of the day, and have that cycle flip every single day. So we're going from a very high, the daytime period, the lights on period where we're needing to remove a lot of moisture, and then the lights shut off. There's no heat load anymore, just like that. And then where we still need to remove moisture, just not quite as much. And so really understanding your watering rates is one of the most important keys to sizing these facilities and these systems appropriately. We can go to the next slide and talk a little bit about the load in general. This could be a 60-minute seminar really in and of itself, of really going deep into the load design and analysis. We put out webinars on this type of topic often. We effectively have two types of load in the space. We have the dehumidification load that we just talked about a moment ago, and we have a cooling heat load in there from the lights. And we need to balance and be able to manage and serve with a system, whether it be, which would be called a non-integrated system that Brian just talked about, or an integrated system where you're doing dehumidification and cooling and heating together with the same system. Really, either way, you need to make sure that we're able to manage and effectively control both the sensible heat load in the space as well as the moisture removal requirement in the space. And that's what, VPD is. If you look at a VPD curve, VPD graph, you have temperature and relative humidity are your two axes on that. So understanding the conditions that we want to maintain in that space based upon the plant growth and the time at which that plant is in the cycle looking for that is going to be what's going to help dictate what environmental conditions we want to maintain. And that changes throughout the cycle, right? So not only does the load profile change every single day from lights on to lights off, it's changing as the plants grow from clones into teens, into early stage flower, late stage flower, and then into harvest. So on the next slide, we can talk a little bit about, and I'll have a better example on the next one to go into it further, of like real number values and comparison of like what Brian was talking about a few moments ago about, air can hold more moisture at a warmer, more humid condition than it can at a cooler, less humid condition, lower dew point condition. And so if we're using a given piece of equipment that has a certain compressor size to it or a certain coil sizes to it, that's going to be able to give you a certain amount of capacity, call it, you're going to ultimately get a different amount of moisture removal capacity out of that same piece of equipment, depending on what condition that room is in and you're looking to maintain at a given time. And so it's really important to understand and work this balance, sort of spinning these plates, if you will, to determine where you should be sizing your system at, and make sure that you're not undersizing it or oversizing it, and really focusing on right sizing it. I see here down in the bottom right, 5-degree lower temp and 5% lower relative humidity almost can effectively double the tonnage and the capacity of that system. And it's all pretty linear from that all the way up to, system size and overall cost and budget that it will take from both CapEx and operating costs, OpEx, to be able to run the facility. So it's extremely important to get these as right-sized as possible, which has been a challenge with a new, really a new plant effectively. It's not, I don't want to say new because it's been, cannabis has been grown for a couple of thousand years. Has it been grown in a very closely controlled environment in a legal framework where you can use, professional HVAC engineers and professional commercial and industrial type of equipment to serve it? No, that's really an advent over the last 2 to 10 years, depending on the state that you're in. And so that's really where a lot of this learning is taking place.
That's an amazing statistic at 5 degrees, 5% doubling tonnage. Thanks. That's so
yeah, I mean, you can, and on the next slide, we can see it. I just took a snapshot. This is a 60-ton DX unit. There's just effectively 60 tons of nominal capacity to it. And you can see even we're not moving the relative humidity here at all. We're leaving that constant at 55%. and we're just moving from 78 degrees to 74 to 70, just as an example to show the amount of moisture removal. Pounds per hour is how HVAC engineers calculate moisture removal. And that's converted over from gallons, basically gallons per day on a room basis that you would put into that space, less runoff. You're going to calculate then how much moisture removal we need on a pound per hour basis. And that's then how we would size the air conditioning system. And so you go from, you're effectively, it's not quite, but almost doubling the size of the capacity of that system in that 8-degree differential. And so, it's really a balance between, and just think if that was 70 degrees, 50% relative humidity, or 70 degrees, 45% relative humidity, that number, that 160 really drops drastically. And so that's why it's so important, why we see so many facilities effectively that, that either way oversized because the numbers weren't really known and there was a lot of guesswork done and a lot of extra safety factor, or really most often what we see are that they're significantly undersized and not able to maintain that the VPD that they want to maintain in that space, in which the plants are going to be able to thrive. We're really looking, we're bringing this all indoors. We're not doing it just to be able to, in some places there is like, hey, I literally cannot grow outdoors for more than 2 months or 3 months in some climates. But in general, and in particularly with cannabis, and also with other vertical farms, you're bringing this indoors to be able to do better, right? We're trying to improve yields. We're trying to improve chemotype, expression out of, the output, all of the different types of outputs from these plants. I think this is a little bit kind of just an interesting spot here. Maybe doesn't flow exactly, but I thought it would be good to just touch on the code changes that are coming up and are about to be implemented in California, since we are all California centric here. Title 24 has made controlled environment horticulture, they call it CEH, but basically any type of indoor plant environment, part of a covered process in the Title 24 Energy Code beginning January 1 of 2023, which is just a little more than a month away. The snapshot here is very similar specific language to what's in the code as it pertains to dehumidification. There's also lighting and greenhouse glazing item that are in there as well. And actually the code period, it says every 3-year code period, code update period, and they just have kicked off the 2025 update period. So this was, it's a call always to get involved if you want to have your voice heard. There was very, I would say, somewhat limited amount of, there's not a lot of facilities that are out there that are operating that are ready to just start sending data out, and talking about their facilities. There are a number of them, but it's been very challenging to get real data from the industry to be able to help inform these code cycle updates. And anybody that's a cultivator that has good data or anecdotes and things that they think could be done or could not be done, I'm a big advocate for having you get involved in the process, because otherwise you end up getting regulated around certain things that you may not like, and you feel like maybe you didn't have the opportunity to have a voice in that. But they really are actively reaching out, trying to get cultivators to be involved in this process. And I think it's a really good thing to do and take advantage of. We also see that many other states end up taking California's codes and adopting them in different ways. And so it's a really important factor in how to be involved in this industry and progression as it really begins to mature more. And the main highlights here are If you're going to use HVAC, integrated type systems, chilled water systems, similar to what Brian was just talking about of those different types, we basically need to be reusing and recovering heat that was generated through the process of cooling. We need to reuse that heat for the reheat, up to about at least 75% of it has to be generated on site to be reused and reheated. So that something like hot gas reheat in a DX system, or heat recovery chillers, like Brian mentioned, in a chilled water hydronic system. So we're now going to jump over to controls, and I'm going to try to buzz through this a little quicker. I'm looking at the.
We do have a quick question.
Yeah.
So from Hervé, there is, what do you assume to be the split between day and night if you start using gallons per day to decide the pounds per hour? 80% of the gallons are transpired during the 12 hours on and 20% off.
Yep.
With a question.
You're pretty darn close there, Hervé. If I said your name right, it's a great question. And I guess we could poll Brian on what they use when they do their sizing. We use between 70 and 75%. And that's what we've found to be pretty industry accepted and widely understood. Again, like Brian said, there are no standards around this. You know, I don't know if Brian personally is, but I know people from Desert Air are involved, and I am as well on ASHRAE TC 2.2, Technical Committee 2.2 is for plant and animal environments. There's a lot of people in the industry that are talking about this and are starting to figure out how to put standards together. But it is really new, and that those standards just don't exist yet. And so that's one of the reasons I've been and all of us have been involved with Resource Innovation Institute for a number of years, because that's been really one of the only ways to get these kind of best practices out there to the masses. But yeah, you're very close there, and it all depends on the light side. It depends on the flower, the phase at which the plant is in as well, as to whether or not. So this, what I just shared of 70 to 75% is based on a flowering cycle of 12 hours on, 12 hours off. Obviously, that would be higher in a veg cycle or mother cycle where you're running 18-hour lights on and 6 hours lights off.
Yeah, I would agree. 75, 25, that's pretty typical.
Yeah.
Great. We should move on. Like you said, we want to get more information to folks. Keep going.
Sounds great. So Brian actually hit this one a bit earlier. So this was just sort of an intro into this controls section here to talk about how important it is to, you know, we if we're trying to really optimize these spaces, we have to be able to control them. And so there's push-pull here. Can the system that you're utilizing be controlled? How well can it be controlled? How deep can you make that control? Is always really one of the first places to start if it's an existing facility. There's really wonderful controlled retrofit opportunities available, and I think Thomas will touch on that as far as what's available from the utility perspective to support as well. But we're looking for optimal plant growth, and trying to control molds, mildews, other pests, and things like that. It's really important that we stay within appropriate temperature and relative humidity parameters. I thought I'd share a little bit on the next slide about the sort of journey to automation, and I think this is take it kind of from a Kaizen type of approach of continuous improvement to really staying as competitive as possible. We've already seen price compression and big price crashes and big supply and demand imbalances, particularly in the cannabis market throughout every single state that's legalized cannabis recreationally, except for a couple that are the brand new ones. It will happen. You have to design for it from the beginning. You have to know that it's going to happen. And you can't go through with blinders on thinking that you're going to sell your finished product for $3,000 a pound for the next 10 years, and that your business model is going to work that way. So that's why it's so important to be always on top of data collection and understanding how automation can really help you drive your financial performance. And that's really the way that we all view controls and automation. You're helping to reduce your labor, and you're trying to help drive better yields and higher profits overall. That's the reason that you would be doing this. There's a number of different controls considerations that you need to think through in how you deploy it. Wired versus wireless has a big, there's upfront cost implications versus reliability and somewhat ease of troubleshooting and things. Sensor placement and density is one that I think is really important to talk about in this space, particularly as we see indoor cultivation rooms going through multi-tier and packing. We're really using the cubic footage of these spaces and not just the square footage of these spaces, and trying to figure out what's the right type of sensor density and placement for second level versus first level, and really making sure that we understand what's going on in that space and we're able to mitigate microclimates.
About 3 minutes for you to finish up, Adrian. Keep going. This is great.
Sounds great. So fully integrated controls is really the opportunity that you have to bring all of the systems together. It's really challenging to do this without the experience, like Rob talked about, of really running the facility. So it's one of probably the most important thing to take away from this is that it's very challenging, and you don't normally hit the mark if you're just trying to control just for control, right? You need to understand the process, and you need to know what it is that you're trying to control to and how and all of that, so that you can put together the control system that's really going to help you help that crop be more valuable, and use that investment that you make really in a financial profitable way. And to me, that's really one of the most important pieces of this. Yes, it allows you to reduce the energy usage, water usage, improve your control overall and reduce wear and tear and all those things. But if you don't have your process dialed in and understand and know what it is that you're after, and how it effectively make sure that you're not going to degrade your product that's coming out, or they sort of use efficiency, go after efficiency measures just for the efficiency's sake, then your overall business is going to suffer as a result. We can probably wrap up here on the next slide, just to sort of start to get, visuals are always really good around controls, to be able to see, hey, is this working well? Are there issues? It's amazing what you can see from a well controlled or a good accurate sensor density and sensor type information from a nice trend graph. They don't normally look like this. This is kind of an anomaly that it actually looks like this, and you can go, oh, I can see where the lights on periods are, where the CO2 is high, which is the black line there, and where the lights off periods are. Many times they're all over the place, and you're then using that as a means of trying to help yourself become more productive and efficient with the facility, using it as ways to target individual systems for better production and better optimization of your process.
Adrian, that was great. I love your mix of technical know-how, but also translating it for all of us, give us rules of thumb and some anecdotes that prove those rules of thumb. And I just point out that when you talked about the visual of those graphics, like in your last slide there, that a good operator, a good cultivator will begin to recognize when the signature is normal and when it's not, and they can even start predicting what the problem is just based on that kind of signature.
Yeah, that's exactly right. Oh, I've got a low load situation in there. Oh, that was a spray event that went on, and that's why my relative humidity spiked.
Exactly.
Oh, I've got a CO2 solenoid valve that that's not operating properly. All of those things.
Really cool when your grower gets to that point. We'll go back to Brian. Brian, we've got about 4.5 minutes for commissioning. Can you step up and share your expertise?
Sure. I'll share all my expertise that I've generated over 30 years in 4 minutes. Yeah, this is kind of dear to my heart here. This whole monitoring and calibration and commissioning, and particularly commissioning, because you always get a better product, a better building, a better operation if you commission. Now, the monitoring, you need to decide up front what you need to measure to make you successful, what the key performance indicators are. You have to remember that your sensors have to be calibrated every once in a while, and they have to be in tune with your equipment so that you're not doing something like short cycling. And commissioning, it is really talked about in ASHRAE about commissioning every building, and that really kind of starts up front. So it's in the design phase. You have to think about it as you're building this project, as you're making design decisions. Think about what you're going to test for. Think about what your key requirements are of that building, the set points you're going to operate, the procedures. You have to look at fail-safe conditions. Really get on top of this so you can step through. And part of this is the design phase. This is where you can make mistakes. Once you start putting in a building, you're screwed. You've already bought the equipment. Now it's too late. And you need to perform a design review and develop a commissioning plan that some independent party can go through and make it happen. And this is where you try to come up with the issues you might walk into. So that design phase, you want to have a building, a facility that is consistent regardless of the season, regardless of what the temperature is outside. One of the things I run into all the time is people get way down this road about design and then discover they don't have enough power to even operate the facility. And that is not an easy fix. You just don't come out and put a substation in by Thursday. It just doesn't happen. And your humidity and HVAC management kind of connects back to your equipment that you're selecting, your basis of design, and then really understanding what reactions you have, what type of responses you want when things do get out of whack, out of your set point range. Then the construction phase commissioning, this is where the building's being built, you got equipment showing up, you've got controls going in, and you should have a checklist to make sure that everything's in place, everything's delivered, everything is connected. And now you start going through to make sure that that sensor actually connects to the piece of equipment that you think it does, not to the piece of equipment next door. And these things happen all the time. You need to figure out, who is going to run this stuff and make sure they get the training. It doesn't help if you have all the sophisticated controls and the guy is big fingering different conditions kind of willy-nilly, and that throws everything off. The idea is to commission it, check it against the parameters you had in the design phase and make sure they're being met. Your requirements for that building are being met. And then the final commissioning report you keep, because somewhere down the line, things might get out of whack. You need to go back to the commissioning report and get things back to where they need to be. That's your, guardrails. That's your bumpers on the bowling alley, if you will. Performance testing of equipment. A lot of times this is very hard without plants in the building. So in some ways, your first crop is going to be experimental. This is where you're tuning your system. And some manufacturers can come in remotely through like a cloud-based system and tune your parameters. One of the control abbreviations that we use are PID loops. This is just a term for a control strategy for the reaction of the equipment. And people can come in and tune these loops so that the equipment is much more effective, because every room is different and the equipment needs to be tuned for that room. And then up front, even in the design period, you need to state what things you're going to collect in terms of data. And this is really important because without this data, how do you know how to get better? Without this data, how can you understand what went wrong with that particular crop, that particular growth cycle? How are you going to compare crops against each other? How are you going to compare rooms with each other if you're not collecting the data? State emphatically what information you need. And part of that could be the energy being used for the equipment serving those rooms, whether that's lights, whether that's the HVAC equipment, maybe you have fans that are circulating air. Track all that so you know exactly how much investment is going in that room for the output you're bringing out of it. And then VPD, or some people work in that term VPD, but my experience is most people talk about temperature and relative humidity, and you need to validate those conditions are within target. Sometimes you'll have sensors in the wrong place. A lot of times the equipment will have its own sensors, and if they disagree, you need to figure out why. It typically means you have a problem with your air distribution, but it's very important to keep tracking that. Say your piece of equipment has a bad filter, it's got plugged up. Now you're not getting any performance out of it. You're going to see it on this graph. You're going to go, oh my God. And now you're going to dive into it and figure out what the problem is. But this is your daily yardstick to assess if you're making progress.
Thank you, Brian. That's great. And data, you're talking to segues beautifully into our benchmarking. And next slide, please.
I was going to say, we do have a quick question about guidelines available for functional testing in CE, Ag, Hort, and Grow. Are there guidelines available of any kind?
I'm not really aware of any functional guidelines. They're like a society set of rules or practices. I'm not really aware of any. And that's really something I think you need to maybe decide for yourself, depending on the crop you're growing. Adrian, you have any ideas there?
Yeah, I don't know of any specific guidelines that are available. It might be worth doing a roundup and getting back, but I would also say, I mean, maybe that's a plug to get involved and helping to write them as particularly TC 2.2 develops, and ASHRAE is putting more resources into developing information. I think it's really a wonderful opportunity.
I second that. Next slide. So benchmarking very quickly. You can come to RAI, and the growers can come, and like I just explained at the beginning of this presentation, we can help you determine your KPIs for energy, water, and emissions, and that's a very simple process. I don't have time to talk about it now, but don't be afraid just to give us a call, write us an email. We can tell you how that works. It's very easy to do. We try to make that a light lift. Next slide. So what will help you determine is your efficiency in KBTUs per square foot of canopy, your productivity in KBTUs in pounds of harvest, and then your annual facility energy use in kilowatt hours per day. Those are just some examples of the sort of KPIs will help you track. And on the right, you can see one printout from our software, and again, you can track your KPIs year over year. Next slide. And this is what we aim for, is you'd be able to track and steer your cropping inputs to and then tracking energy efficiency, water efficiency, we measure that as well, nutrient efficiency, and CO2 efficiency. I'm going to stop the benchmarking there and turn it over to Thomas Lohr, engineer from Southern California Edison, to tell us a little bit about the financial incentives. Go ahead, Thomas.
Thanks, Rob. So good afternoon, good evening, depending on where you're logging in from. So one of my core focuses is to coordinate and promote all things energy efficiency, primarily with our CEA customers. The IOUs, the investor-owned utilities, recognize that CEA operations are very complex, very energy intensive, and we'd like to do everything that we can to help customers in this segment operate more efficiently, which means lower energy costs and, of course, boost to the bottom line, as Adrian was alluding to earlier. Of course, energy efficiency strategies, equipment often come at an upfront capital cost premium to standard options. So, to help customers learn more about these options and to hopefully adopt them with the help of financial incentives, we currently have a couple offerings that I want to talk briefly about today. The first being the Summer Reliability Program. This program benefits customers with existing operations within our service territory. It leverages our CEA industry partners, can be designers, consultants, vendors, distributors, to create their own incentives and rebate offerings that they believe will be most attractive to the end user. It's performance based, which means that it takes into account the customer's actual energy usage measured at their meter, to determine the kind of before and after impact of the energy efficiency measures that they choose to adopt. And I'll talk a little bit more about that on the next slide. And then the other program that we have available to customers in this segment is the California Energy Design Assistance Program, otherwise known as CEDA. And this program benefits customers that are embarking on new construction or major renovation projects. It is actually administered by our friends to the north, PG&E, and implemented by Willdan, a third-party company that is contracted to help deliver the program statewide. CEDA is meant, like I said, it's actually meant for all commercial new construction, but they do have expertise that know the CEA segment very well. And I think we can move to the next slide. I can talk a little bit more in detail. So the Summer Reliability Program, as I said, it doesn't, unlike the more traditional programs, it's actually a contract between Edison and our trade professionals, which, like I said, can include anything from an energy consultant to an MEP firm to a lighting manufacturer, HVAC manufacturer, and the contract is between us and them to be able to come up with creative ways to help drive energy efficiency adoption. It's a temporary program that it's supposed to run through the summer of 22, start running from the summer of 22, through the summer of 2023. There's a large budget for it statewide. All I will say is that, what we're seeing in terms of programs, that are kind of born out of this is, equipment rebates or equipment being offered to customers at a significant cost savings. So if you are embarking on a project in a retrofit, do talk to manufacturers, whether it's HVAC, lighting, controls, and ask them about this program. Let them know that it exists if they're not already participating, because there can be some very lucrative opportunities here. And then next slide really quickly. I know we're at time. So
right.
As I mentioned before, CEDA is for new construction. It is offered statewide. Some of the complementary services offered are comprehensive whole building energy analysis, help identifying EE measures within your specific facility, and then help with engineering economic analysis to determine, to make decisions on which ones to move forward with. And then of course, typically there's an application with, once those decisions are made, there's an application to be able to qualify for incentives that come along with that. I will move on really quickly to, so actually real quick, in addition to SRP and to CEDA, we are working behind the scenes to come up with additional programs, to hopefully make energy efficiency, to make that process, to make the adoption of energy efficiency technologies more accessible to our customers. And then in helping along with all that, we have other services such as our tool lending library. PG&E has one, SCE has one, where customers can actually rent equipment ranging from anything from infrared thermometers to data loggers to help monitor or sub-meter their usage. So that's available. And then I believe that'll be it. So I think this slide is going to be, this deck is going to be shared with everyone here. And you can see, there are hyperlinks to everything that I just talked about. And then of course you can feel free to reach out to any of us if you have questions after this.
Wonderful. Thank you, Thomas. That $60 million budget for the summer reliability program, that just is jaw dropping. So thank you for that. And thank you for explaining that. And thank you for SC&E for sponsoring this. A lot of people may need to jump off, but maybe we'll stay on, ask the panel to stay on for another minute or two in case we have any other questions. I think we've answered all the questions in the chat, but I am going to open it up just to see if there's anything else before we say good night or good afternoon. I'm looking over at my chat window to see if there's anything. Okay, we'll sign off then. Well, for Carmen Azzaretti, I'm Rob Eddy with RII, and we'd like to thank Adrian Giovenco of Inspired Transpiration Solutions, Brian Kammers of Desert Air, and Thomas Lohr of SC&E for a fantastic webinar. I learned a great deal. Hope you all did.